Find the second derivative f double prime of x for the function f of x equals 2x minus 1 to the 6th times 3x minus 4 to the 4th. Then evaluate f double prime of 1. So f of x here is the product of two functions. We have the 2x minus 1 to the 6th and the 3x minus 4 to the 4th. For the derivative, we will therefore make use of the product rule. To find the second derivative, we will start by finding the first derivative, f prime of x. Using the product rule, the derivative of the first, bring the power down, leave the inside alone, subtract 1 from the power, multiply by the derivative of the inside to complete the chain rule, times the second left alone, plus the first left alone, times the derivative of the second. Bring the power down, leave its inside alone, subtract 1 from the power, and then multiply by the derivative of the inside to complete the chain rule. So our first term, if I collect the constants together, I have a 6 and a 2, 12, 2x minus 1 to the 5th power, and 3x minus 4 to the 4th power, plus the second one I have a 4 and a 3, so also a 12, and I have a 2x minus 1 to the 6th and a 3x minus 4 to the 3. Now it is possible to factor this, but factoring makes it more difficult to find the derivative. We actually will want to leave it like this and find our next derivative from here. Now because we have two terms combined by addition, we can take the derivative of each term separately. Well, each term is itself a product rule, so we're going to have two product rules for our next derivative. F double prime of x will be, so we're going to work with this one first, that term there, which is the product rule. So we're going to take the derivative of the first, we're going to bring the 5 down, multiply it with the 12, subtract 1 from the power, multiply by the derivative of the inside to complete the chain rule, times the second left alone, plus the first left alone, times the derivative of the second. Bring the power down 4, leave the inside alone, subtract 1 from the power, multiply by the derivative of the inside to complete the chain rule. That completes the derivative of the first term. Now we have the second term. Same thing with this one, we have a product rule. So we'll take the derivative of the first, bring its power down, leave its inside alone, subtract 1 from its power, multiply by the derivative of the inside to complete the chain rule, times the second left alone, plus the first left alone, and then the derivative of the second, bring its power down, leave the inside alone, subtract 1 from the power, and then multiply by the derivative of the inside to complete the chain rule. So, our second derivative, f double prime of x, will be, what we can do with this is collect the constants together to make this look a little nicer. So this first term we have a 12, a 5, and a 2. 5 times 2 is 10, times that 12 will give us 120. So we have 120, 2x minus 1 to the 4th, and 3x minus 4 to the 4th. The next term we have a 12, a 4, and a 3. 4 times 3 is 12, times the other 12 is 144, so plus 144. We have a 2x minus 1 to the 5, and a 3x minus 4 to the 3. The next term we have a 12, a 6, and a 2. 6 times 2 is 12, times the other 12 is 144. And we have a 2x minus 1 to the 5 and a 3x minus 4 to the 3. And then the last term we have a 12, a 3, and a 3. 3 times 3 is 9, times the 12 is 108. And we have a 2x minus 1 to the 6th and a 3x minus 4 squared. Now these two middle terms are actually the same powers for each of the expressions, 2x minus 1 to the 5th and 3x minus 4 to the 3rd. So we can add those together. We may want to do that. It will simplify our work needed for evaluating. And it will simplify the look of our second derivative. So we have 120, 2x minus 1 to the 4th, times 3x minus 4 to the 4th, plus 144 plus another 144, so 288. 2x minus 1 to the 5th, times 3x minus 4 cubed. And then we have our last term, 108, 2x minus 1 to the 6th, and 3x minus 4 squared. This can be factored, and we can factor any common factors from the numbers. And we have 120, a 288, and 108. Now, 4 divides each of those. And if you divide 4 into 120, you get a 30. And if you divide 4 into the 288, we get a 72. And if we divide 4 into the 108, we get a 27. Each of those themselves have a common divisor of a 3, so it sounds like we can factor out a 12. Looks like each of these are divisible by a 12. So we can factor a 12 out, and we'll have 12 times then 10, 2x minus 1 to the 4th, 3x minus 4 to the 4th, plus 12 divided by into 288. We'll go in 24 times, 2x minus 1 to the 5th, 3x minus 4 to the 3rd, and then 12 divided into 108 gives us a 9. 2x minus 1 to the 6th, and 3x minus 4 squared. The next thing we want to do here is factor out any common factors of powers, and we have some common factors of powers. Looking through here at the 2x minus 1s, we have it to the 4th power, to the 5th power, and to the 6th power. We can take out the lowest of that. That'll be the 4th power. So I can factor out a 2x minus 1 to the 4th power. And then the 3x minus 4, we have a 4th power, a 3rd power, and a 2nd power. We can take it out to the 2nd power, the lowest of each of those. So 3x minus 4 to the 2nd power. Now if we factor from this first term, we'll keep the 10. Now notice we're taking out 4 powers of 2x minus 1, so that means we will remove all of these. We'll take all of them but 1 from this one, and we'll take all of them but 2 from this one. And we're taking out 2 powers of these, so we will take all of this but 2 of them. all this but one of them, and then all of that. And there's what we will have left over if we do this. So there's the look of what we will be writing inside of here. And that means we will have a 3x minus 4 squared. We will have a 24 times a 2x minus 1 and a 3x minus 4. And we will have a 9 times a 2x minus 1 squared. Now our next step, we can FOIL each of these out and distribute the numbers into them. And that will give us f double prime of x equals 12 times the 2x minus 1 to the 4th times the 3x minus 4 squared times, and we will have 10 distributed into 3x minus 4 times a 3x minus 4. We will have a 9x squared, a negative 12x and another negative 12x, so a negative 24x, and then plus a 16. We will have a 24 times 2x times 3x is 6x squared. We also have a minus 8x and a minus 3x, so minus 11x, and then a plus 4. And we have a 9 times 2x minus 1 times 2x minus 1. 2x times 2x will be 4x squared. We will have a minus 2x and another minus 2x. It's minus 4x, and then a plus 1. So we have a 12 times 2x minus 1 to the 4th times 3x minus 4 squared times, now for our x squared terms, we can combine everything now. We have the 10 times the 9, the 24 times the 6, and the 9 times the 4. 10 times 9 is 90. 24 times 6 is 144. And 9 times 4 is 36. Now 144 plus 36 is 180, plus the 90 will be 270. So we have a 270 x squared. We have a 10 times negative 24x, a 24 times negative 11x, and a 9 times negative 4x. And 10 times negative 24 is negative 240. 24 times negative 11 is negative 264. And 9 times negative 4 is negative 36. Negative 264 and negative 36 combined is negative 300. And then we have the 10 times the negative 24, negative 240. So negative 540 altogether. And then times x. And then our constants, we will have a 10 times a 16, a 24 times a 4, and a 9 times a 1. Times 16 is 160, 24 times 4 is 96, and 9 times 1 is 9. 96 plus 9 is 105, plus the 10 times 16, which is 160. 105 plus 160 is 265. Now it is possible to factor that a little further, because each of these numbers are divisible by a 5 here. So we can factor a 5 out, which will move out with the 12. So f double prime of x will be, factoring out 5, I will just call this 60, and then 2x minus 1 to the 4th, and 3x minus 4 squared. We will have, after factoring a 5 out, 54 x squared minus 108x plus 53. That's as factors as we can make it. So there's our second derivative f double prime of x factored. Now the other thing we want to do here is evaluate f double prime of 1. And that will give us 60 times 2 times 1, which is just a 2, minus 1 to the 4th. 3 times 1, which is a 3, minus 4, and then squared. And then this times 54 times 1 squared, which will be 54, minus 108 times 1, which will be a minus 108, and then plus 53. Now, even though this looks bad at first, it turns out that, well, 2 minus 1 is a 1 to the 4th. 3 minus 4 is a negative 1 squared. And 54 and 53, if you add those together, that's a 107 minus 108, and that's all just a negative 1. So even though they look bad at first, they're not too bad. So 60 times 1 to the 4th, which is a 1, times a negative 1 squared, which is a 1, and then times a negative 1. 60 times 1 times 1 times negative 1 will give us overall a negative 60.